Alright guys, so I'm going to rush through this video, make sure I'm recording. Yep, but I'm going to go quick. So you're going to have to be paying attention or pausing, and writing some of these notes down. But here's the notes. I realize you probably can't see these down here. I was running out of space trying to figure out how to do this. But either way, I'll get there. Hopefully I can remind myself to actually make these a little bit bigger so you can see them on the video. But these are going to be notes about solving inequalities, and it's just like solving an equation, all right? So first of all, inequality signs are signs like this, so less than, okay, that's strictly less than, strictly greater than. What you see here is me reminding myself that's actually less than or equal to, but I couldn't do that on the computer very easily, so less than or equal to, like this, and it has a little line below it. And that's signifying also like an equal sign. So it's less than or equal to. That's what that sign is. I'll just write it right over the top of this. Less than or equal to. And this one is specifically greater than or equal to. All right. And so an example of a strictly less than equation would be like x is less than 3. Okay. And that's what this little part says right here. X is less than 3. And what that would look like on a number line is if you had 0, 1, 2, 3, like this. X being less than 3, that means x can be any number, like 2 is less than 3, 1 is less than 3, 0 is less than 3, all your negatives are less than 3. So it would be multiple answers, actually infinite answers, anything in this direction on the number line. So look, here's 3. It's not talking about anything bigger than 3. It's saying x is less than 3. And so you see that open dot, that signifies that it cannot equal 3. It has to be strictly less than. So here's what it would look like. I'm going to erase this now. So that's what it would look like for x is less than 3. Now talking about, and let me write that one more time, actually. Now talking about x is, what would it look like for x to be less than or equal to 3? So it's very similar. It's 0, 1, 2, 3. Now the only difference is x is still less than 3, so here's what x is less than 3 look like. But less than or equal to, it can also equal 3. So you have this filled in dot where the line actually hits 3. On this one, the line stopped. I guess I shouldn't have erased that. 0, 1, 2, 3. And notice this one is open on 3 because x cannot equal 3. So x is strictly less than 3. This one is x is less than 3 or equal to. And that's why it's closed with that equal to part. For greater than, so it would look like this. It would be x is greater than 3. And what that would look like is, say you have a line 0, 1, 2, 3. X being greater than, so it's not 2, it's not 1, it's not 0. These are all examples of things that are less than 3. If x is greater than, then it's like 4, it's 5, it's 6, it's 100, it's numbers bigger than 3. But notice, again, it's strictly greater than, so it's an open dot going in that direction. And that's how you would write your solution to that. X is greater than or equal to, so same idea, 0, 1, 2, 3, and you can put other numbers than 0 here. You don't even have to have 0. Typically, I like to put 0 though as some kind of place marker. It's just what divides the negatives from the positives. So I like to use the number 0 in my number line. But ultimately, you can put whatever numbers you want here, as long as you've got 3 included in that. So if x on this one is greater than or equal to 3, and if x is greater than or equal to 3, notice it's a closed dot. And it's pointing, your arrow's pointing to any numbers that are greater than or equal to 3. And that's how, those are 4 examples of less than, greater than or equal, or less than or equal. Okay? Now, let me talk specifically about something that people tend to confuse. And I'm going to bring this back to like elementary school because I think it's the best way to understand this. The way you know that typically, in my mind, I do not think of the words less than or greater than as much as I do just what's bigger than the other. So in elementary school, I remember one of my teachers talking about how the mouth opens up and eats the bigger number. And for some reason that always stuck in my head. So if you have struggle with like the words less than or greater than and which sign goes with which words, then just remember that when you see an example like this, so let me write it a little bit bigger. When you see an example like this, x is less than 3, remember this, that mouth is eating the bigger number. Okay, the mouth opens toward the bigger number. So that's saying that 3 is bigger than the x, so x has to be smaller, or that's where you get the words less than from. Now, if it's pointing this direction, remember the mouth is eating the bigger number, so that's saying x is bigger than 3. Okay, and that's where you get that greater than word from. X is greater than 3. Okay, so x is all the numbers bigger than 3. Okay, and then again, it's the same concept just with equal signs. X is greater than or equal to 3. It's a bigger number than 3. Or x is smaller than or equal to 3. So x is a smaller number. 3 is bigger than x. The mouth is eating the 3. Okay, going on to some other notes. Some important things to take note of for later on is if you ever divide or multiply by a negative number when you're solving an inequality, the sign flips directions. So for example, man, I wish I had somewhere to write this. Let me do it like this. I'm going to move up here. So say this was an inequality sign. I'm going to turn this into an inequality. So this is greater than or equal to. So as I'm solving this, let's do this one. Greater than or equal to. And the reason I'm doing this one is because that negative right there. So as I'm solving this, start off, subtract 1 from both sides. So I end up with negative 2x is greater than or equal to negative 4. I'm going to divide by negative 2. Now here's the part where it changes. When I divide by negative 2 on both sides, yeah, great. Negative 2's cancel. I get x, but look at the sign. I divided by negative, so I'm switching the direction of the sign. Negative 4 divided by negative 2 is positive 2. All right, and one more time just for a recap, the way you graph that, if x is smaller than that 2, so here's 0, here's 1, here's 2. If x is smaller than or equal to, it's going to be a closed dot because it's got the equal to, and then it's going to be pointing to any numbers that are smaller than or equal to 2. Okay, so there's an example. Now the rest of this video, I'm literally just going to plow through a few examples. All right, so I don't know if you guys can see this. I've already worked a few of these examples, so I'm actually just going to move on in the video. So solve each inequality. So the first one, I'm just going to solve them one by one. I'm going to rewrite them down here. And then check your solution, then graph it on a number line. So t minus 12 is greater than or equal to 16. So to solve this, for t, I'm going to add 12 to both sides. 12 cancels. T is greater than or equal to 16 plus 12 is 28. So t is greater than or equal to 28. Now the way to solve that, or to check it, so I solved it, now I'm going to check it. The way to check it is pick a number that's bigger than 28. I'm going to pick 30. 30 is bigger than 28. So if I plug 30 into this equation, it should work out. So let me go ahead and try it out. So 30 minus 12 is greater than or equal to 16. Is that a true statement? What's 30 minus 12? 30 minus 12 is 18. Is 18 greater than or equal to 16? It is. So we've solved it correctly. And so I've solved my inequality. I've checked my solution. Now I'm going to graph it on a number line. So what would that actually look like? Well, on a number line, if t is greater than or equal to 28. So in this case, I don't have to have 0. I'm going to do it like this. I'm going to start off at maybe 25, 26, 27. This is poor use of space right here. Let's do this again. Let's start off with 25. That's still fine. 25, 26, 27, 28, 29, 30, something like that. Where you can, the reason you're picking numbers is so you can have an idea of where this dot actually is. So t is greater than or equal to, that's a closed dot. I'm pointing to the numbers that are bigger than 28. So notice the t is bigger than 28, so you're pointing to all the numbers that are bigger than 28, all the numbers that t could represent. Okay, so that's the first example. I'm going to go ahead and leave my number line up there. All right, next one was n minus 12 is less than 6. So I'm also going to stop checking my answers just for the sake of time. But remember to check your answers. All right, so solving this, plus 12, n is less than 18. So again, if I'm going to check it, I would just pick a number that is smaller than 18. Like 15, and I'd plug 15 in there. So that means 15 minus 12, which is 3, is less than 6. So that actually checks off. It works. Now graphing it, let's say I'm going to pick 16, 17, 18, 19, 20. That's plenty. N is less than, so it's a smaller number than 18. 18 is the bigger number. Remember, it's an open dot because it's strictly less than. And then it points to all the numbers that are less than 18. All right. Another one. Number 3 here is third example I want to go over. G minus 3. Solve this one for G. So G is on the right side, so I want to get rid of the 3 from the right side. Those cancel, so 9 is less than or equal to G. All right, so if I was going to check that, that means G, look at the mouth, it's bigger. So G is bigger than 9, so pick a number bigger than 9, like 10. And check it, so plug 10 in here. 10 minus 3 is 7. 7 is greater than or equal to 6, so it's a true statement. So we've checked it. Now we're going to actually graph this. So let me show you another way of graphing it maybe. Yeah, sure. Let me show you another way of graphing this. You don't need all the numbers necessarily. You really just need to be specific. So let's say we put a 0 on there. Let's say 9 is over here somewhere, so I'm just going to put a 9. Now those are the important numbers. 9 is really the most important. So if G is less than, or I'm sorry, if G is greater than or equal to 9, so there's 9, it's greater than, needs to be going that way. Okay? That's another way. That's probably the lazy man's way of graphing these things. Okay. Graphing inequalities. All right, next one. Solve each inequality and check your solution. Okay, so number 7 right here says negative 3x less than or equal to 8 minus 4x. So to solve this, I need to get my x's together. I need to combine my like terms, but I'm combining over the top of one of these equal signs. So I'm going to have to actually move things around using properties. So when I add 4x to both sides, the x's cancel here, and I can combine them over here, which is what I wanted. Negative 3x plus 4x is just x, still less than or equal to 8. Notice I haven't yet on this video divided by a negative, and that's why our signs haven't changed directions yet. All right, but when you divide by a negative or multiply by a negative, your signs change directions. Oh, and it says check your solution. So x is less than or equal to 8, so I'm going to pick a number that is less than or equal to 8. So here's interesting. Let's pick 8 because 8 is less than or equal to 8. So I'm going to choose 8. That means negative 3 times 8. Negative 3 times 8 is less than or equal to 8 minus negative 4 times 8. I'm sorry, minus 4 times 8, which is 32. So that's negative 24 is less than or equal to negative 24. True statement. Negative 24 equals negative 24. So, yes, negative 24 is less than or equal to negative 24. So that works. Next one says 0.6 n is greater than or equal to 12 minus 0.4 n. So I'm going to add 0.4 n to both sides. These cancel. So I'm going to have 1 n over here, so I could write 1 n, but I don't have to. Just going to put an n greater than or equal to 12. There's my answer. If I wanted to check it, I'd pick a number bigger than 12. So I could pick, or equal to. I could pick 12, 13, 14, 15, any number I want that's bigger than or equal to 12, plug it into my original inequality to see if it actually is a true statement. So last one on this type of example, negative 8k minus 12 is less than negative 9k. Alright, so solving this, I'm going to go ahead and let's do it this way. I'm going to add 8k to each side. What I was doing in my head just then was, do I want to add 9k to each side and then, or do I want to add 8k to each side? So which side do I want to remove the k's from is pretty much what I was thinking. So I decided to remove them from the left side. So I end up with negative 12 is less than negative 1k. Now, the reason I did that was because I wanted to give you an example of actually switching the sign. Okay, so if I want to solve for k, I need to divide that negative 1 off. So I need to divide both sides by negative 1. And I talked about when you divide by a negative, that sign flips directions. So this is going to be negative 1 divided by negative 1 is positive 1k. But this sign switches directions. So k is less than positive 12. And if I want to check that, pick a number that's less than 12. So for example, it can't be 12 this time because it's not less than or equal to. But if 12 is greater than k, maybe use 10. Plug 10 into this equation and see if it works out. All right, that's that example. Okay, last example. It says define a variable, write an inequality, and solve each problem. Check your solution. Okay, so I'm going to start off defining a variable. So notice it says a number decreased by 4 is less than 14. If you can't read that, it says a number decreased by 4 is less than 14. Okay, so a number, I'm going to call that, I don't know what the number is, there's my variable. So when it says define a variable, that's what it's talking about. So x is going to represent a number. Decreased by 4. So when I write out my equation, x decreased by 4. So if I took that number and I subtracted 4 from it, I'm decreasing it by 4. Then it says is less than. So that thing has to be smaller than, it's less than some other number, or less than 14. Okay, so x decreased by 4 is less than 14. So I've written an inequality. Now I'm going to solve it. So if I'm going to solve this, I need to add 4 to each side, which means these 4's cancel, so x is less than 18. And if I'm going to actually check my solution, so there it is solved. If I'm going to check it, I just need to pick an x that's smaller than 18. So something like 15, take that, plug it in, and check my solution. I'm going to do one more example, and then this video will be over. Okay, so the difference of two numbers is more than 12, and one of the numbers is 13. You know what? I'm going to skip this one for now because it's talking about two numbers, so now you're going to get into two variables like x and a y, and it says the difference of two numbers. So x minus y is more than 12, and one of the numbers is 3. That's so much different than anything we're doing. I guess I'll finish it because I've already started it. But it says, all right, the difference of two numbers. So x minus y. Two numbers subtracted from each other. The difference of two numbers is more than. So it's going to be greater than 12. One equation. Now, I don't know why the heck this is on here. And that's a whole nother, it's talking about a whole nother inequality. One of the numbers is 3. Okay, so y is 3. There's another thing. So that's kind of just a crazy example. But don't worry about that one. Guys, if that confused you, number 13 is really what you're focused on now. We'll get to things like that later.